Hey guys, Mike here, and this is going to be part one of the basic land navigation series. In part one, we're going to be covering marginal information on a map. It is very important that you do not skip this part of the navigation series. Understanding marginal information on a map is critical to being able to use the map effectively. All it really is just useful information that explains how to read and use a map. So, this series is going to be a short summary of all the pieces of marginal information on a map. Not understanding this information can lead to serious errors and get you lost while trying to navigate. So we'll start with the first piece of information. The first piece of information we're going to go over is the sheet name. The sheet name is found in bold print at the center of the top and in the lower left area of the map margin. A map is generally named for the largest settlement contained within the area covered by the sheet, or for the largest natural feature located within the area at the time the map was drawn. In this case, we're going to be looking at 29 Palms West, the Marine Corps Air Ground Combat Center. That's the map I have with me. There are two maps to the whole combat center. There's east and west. So right now we're looking at west, and we'll go over what to do if you have two maps that pertain to that area. Next, we have the series name. The map series name is found in bold print in the upper left corner of the margin. The name given to the series is generally that of a major area, such as a state within the U.S., or a European nation, or other smaller nations. A map series usually includes a group of similar maps at the same scale and on the same sheet lines or format designed to cover a particular geographic area. It may also be a group of maps that serve a common purpose, such as city maps. Next, we have the scale. The scale is found in both the upper left margin after the series name and in the center of the lower margin. The scale node is a representative fraction that gives the ratio of a map distance to the corresponding distance on the Earth's surface. For example, the scale note 1 in 50,000 indicates that 1 unit of measure on the map equals 50,000 units of that same measurement on the ground. 1 in 50,000 is the most commonly used military map scale. Next, there's the adjoining sheets diagram. Maps at all standard scales contain a diagram that illustrates the adjoining sheets. The diagram usually contains 9 rectangles, but the number may vary depending on the locations of the adjoining sheets. All represented sheets are identified by their sheet numbers. Sheets in an adjoining series, whether published or planned, that are on the same scale are represented by dashed lines. The series number of the adjoining series is indicated along the appropriate side of the division line between the series. In the lower margin, you're going to have the declination diagram. On large-scale maps, it indicates the angular relationships of true north, grid north, and magnetic north. In recent edition maps, there is a note indicating the conversion of azimuths from grid to magnetic and from magnetic to grid next to the declination diagram. This is one of those things that can change from place to place. Even going across the U.S., the angle between grid and magnetic north can be a lot bigger or smaller. Now, true north is just running along the north and south poles, and your grid north, which is the north and south running lines on your map, will try to match up to that as much as possible. But remember that the Earth is round, and all these grid lines will eventually converge, so that will cause a small shift or a slight angle between true north and grid north. Mainly what you need to pay attention to is grid north and magnetic north. In order to convert grid to magnetic or magnetic to grid angles, as you're using your compass or your map in order to read the direction which you want, where you want to go. So if you have ever heard any rules like going from magnetic to grid, you add because you're going from major to general, like in a military rank, or if you're going from grid to magnetic, you subtract because you're going from general to major. Those little rules will apply in certain places, but in certain places it won't. So you always need to make sure you check the declination diagram that goes specifically to your map, because it will change in different parts of the Earth. Next, we have bar scales. Bar scales are located in the center of the lower margin. They are rulers used to convert map distance to ground distance. Maps have 3 or more bar scales, each in a different unit of measure. Since we're talking about land navigation, nautical miles we're not really going to use. Statute miles and kilometers is what you want to use, but kilometers is preferred since all the grid squares on your map are going to be in kilometers anyway, so it makes it that much more easier to really convert it. Also, if you use a map protractor, that's going to be used in meters as well. So trying to convert it to miles is just going to be time consuming and confusing if you don't do it right. Next we have the contour interval note, or the contour diagram. This is usually found in the center of the lower margin and normally below the bar scales. It states the vertical distance between adjacent contour lines of the map, and when supplementary contour lines are used, the interval will be indicated. In recent edition maps, the contour interval is given in meters instead of feet. You will want to pay attention to this when using an unfamiliar map to get an idea of the terrain you'll be facing. So some of the maps might be 20 meters, some of the maps might be 10 meters, and like I said, it could be in feet on older maps. It just depends on where you get the map from, so make sure you pay attention to that when you read the contour intervals. Also in the center lower margin, you're going to have a grid reference box. Grid reference box contains instructions for composing a grid reference. In it, you'll find a sample of a 1,000 meter grid square and how to find a 6-digit grid, which will get you within 100 meters of your destination. You'll find a 100,000 meter square identification and the grid zone designator. The 100,000 meter square identification just is a 2-letter code that goes from every 100,000 meters. Obviously your grids are going to start with 2 digits from 00 all the way to 99. Now the Earth's much bigger than that, so once it starts over again, it starts with a new square identification. Then you have your grid zone designator, which is usually a number followed by a letter. Grid zone designators are much larger areas, and they contain more of the square identifications. So here's a better look at the grid zone designators. In this picture you can see the smaller squares with the 2-letter codes. Those are the 100,000 meter square identifiers, and you can see how many of them fit into one grid zone designator. Generally they go by 6 and 8 degrees longitude latitude, and you can see how big they are here. You go 1 papa, 2 papa from west to east, and from south to north you go alphabetically, so November, papa, and then the next letter and the next. So that's how grid zone designators work. Next we have the legend. A legend is located in the lower left margin. It illustrates and identifies the topographic symbols used to depict some of the more prominent features on the map. The symbols are not always the same on every map. Always refer to the legend to avoid errors when reading your map. Alright, here we have the colors of a map. Now, you have 6 colors, black being the first, and that's going to be all your man-made features that are other than roads. Blue are going to be your bodies of water, creeks, streams, lakes, rivers, larger bodies of water are always going to be blue, and how the map depicts those different bodies of water will be found in your legend. Green is going to be your vegetation, and again, depending on what type of vegetation it is going to be depicted in your legend. And then we have reddish brown. Reddish brown is going to be all your cultural features, contour lines, and your main roads, your 3-way, 2-way roads, highways, freeways, things like that. On older maps, you'll have red and you'll have brown. Red being populated areas, and brown being relief features like your old contour lines. Now, the reason new maps use reddish brown is so that you can use these maps with a red light at nighttime. If you use a white light in the middle of the night to read your map, it's going to reflect that light back into your eyes and you lose your natural night vision. So we use red light to read the map, and the reddish brown will actually show up. A side note to that, also don't use red map pens when drawing on your map or marking things on your map, even if it's an enemy position for tactical or combat use, because you're not going to be able to see it under red light. Also, red lights do not make you invisible at night. They can be seen from a long distance, so also make sure that you're covering yourself up using a poncho or finding a good piece of cover before you pull out a map and flash a red light on it. Alright, well that concludes part 1 of the basic land navigation series. Stay tuned for part 2. We'll be going over contour lines and terrain features.